Okay, so for second one, what did you guys get? What was the amplitude? A half, positive a half, not a negative a half. It's got to be the absolute value. And what was the period of that function? Pi, 2 pi divided by 2, which is pi. Third one, what is the amplitude here? 2 over 3, positive 2 over 3. And what's the period? It's going to be pi divided by, b value is 1 over 6, which is the same as 6 pi. Right, so that one's a bit tricky. Pi divided by 1, not 2 pi divided by 1 over 6, it's a tan function. Tan function has a period of pi. Pi divided by 1 over 6, which is 6 pi. Alright, we'll try and start the next example. We probably won't get a chance to finish it. Now that we know what a tan, sine and cosine graph looks like, we're going to try and do some basic transformations to it, just phase shift and vertical displacement, nothing more than that. Right, and then the next lesson we're going to add some more complicated transformations to that. So by looking at that function y equals tan of x plus pi over 2, what do you think is the phase shift of that function? Just like working with transformations. Pi over 2 units to the left. So if I wanted to graph this function and then graph y equals tan of x plus pi over 2 in the domain 0 to 2 pi, here's how I would go about doing it. First things first, I want to graph the original function. I only want to graph it in the domain 0 to 2 pi. I'll start off at 0. I'll use the space maximum because I'm moving it left or right. I don't want to use up the entire space, so I'll just go, let me say this is pi up to here. And then this is 2 pi, which means half of that's going to be pi over 2, going to be 3 pi over 2. Now the original tan function, I know that it's got asymptotes at pi over 2 and 3 pi over 2. It's got zeros at 0, pi and 2 pi. And then it passes through pi over 4 and 1. So I'm going to have a tan graph that does this. That's going to be negative infinity to positive infinity, again passing through 1, 1, and then negative infinity all the way to the 0. Right, that's the original function, y equals tangent of x. Now I want to graph that same function having moved pi over 2 units to the left. If I want to graph this having moved pi over 2 units to the left, I'm going to take all the points, move them pi over 2 units to the left. I'm going to keep in the same domain. I'm only going to try and fill in that domain. Imagine your screen was only that big. What would you see? Well, you will see that the asymptote is now moved over here, pi over 2 units. This asymptote's now moved over here. The 0 is now moved over here. And this 0 is moved over here. And another asymptote's now shown up over here, which was originally not in our domain. Right, and your graph is moving to the left. So it's now going to do something like this. So your new graph is going to look something like that. And the key idea is I'm not changing my domain, I'm just filling in the gaps. Right? Whatever extra happened to the graph, I'm going to do that. You should be able to complete your homework. Again, a few more examples. We'll finish this off beginning of class tomorrow. But you should be able to finish most of your homework. Okay? That's the end of that.